So in number 11, this is where things are really going to heat up because we have bases. They're not the same, 125 and 25, and we'll actually have to do two substitutions. So 125 and 25 are both powers of 5. 25 is the same thing as 5 squared, and 125 is the same thing as 5 cubed. So we'll have to do a substitution with both the left and the right. So this is a bit trickier of a problem simply because we have to be aware of the fact that maybe one of the bases is not by itself a power of the other base. We might need to do more than one substitution in these problems. Note there's still a power to a power rule going on the left. 5 cubed raised to the y power, well, that just means 3y is the exponent. Over on the right, 5 squared, well, we just want that exponent there. Our one-to-one property tells us that those exponents are equal. To get y by itself, we divide by 3. So y in this case is just 2/3. So weirder because we have two substitutions. The algebra itself is no worse than it was in the previous example. We just need to be a bit more resourceful with our table. Let's take a look at another one. 16 and 8, those are both powers of 2. If we clear this off here, powers of 2, there's my 16, there's my 8. So 8 is 2 cubed, 16 is 2 to the 4th. So now we'll have two substitutions, but there's also two power to a power properties. Let's make the equal sign red. Oh boy, color. So again, same algebra we've been doing, there's just a bit more of it here. There were two substitutions to worry about, which left us with two power to a power rules, one of which is a distributive property. I'll go ahead and write out all the work here. We'd have a 4 times 3x, and we would also have a 3 times x plus 2. Note that the 4 and the 3 here are coming from those inside powers, whereas the 3x and the x plus 2 are my original exponents. So again, the algebra here is still like algebra 1. 4 times 3x is a 12x. On the right-hand side, there is a distributive property there. 3 times x is 3x, and 3 times 2 is 6. I'm definitely not worried about your ability to do the algebra here, because this is algebra 1. What's tough about this problem is this original setup from our given information, going to the table and getting those correct substitutions. So absolutely raise a hand if you're getting stuck on where any of those original numbers are coming from, the stuff that's in blue up there, or any of the arrows here. It's easy to get lost right here. Once you're down in the weeds with the algebra, it's not too bad. It's a pick on the little guy problem. Subtracting 3x from both sides, move all my variables to the left. I don't have any constants on the left, so that's a step we get to avoid. 12 take away 3 is 9. And if 9x equals 6, well, dividing both sides by 9 there will give me 6/9, which reduces to 2/3. Hey, that looks familiar. 2/3. 13 isn't too much crazier. 4 and 8 are both powers of 2. So you can replace that 4 with a 2 squared. You can replace that 8 with a 2 cubed. Keep in mind, we do still have those original exponents as well. So this problem is going to feel very similar to the previous one, just with different exponents. Once again, I'll show all the work here. So on the left, we'll have a 2 times 3x. That's from our power to a power rule. And then on the right-hand side, I'll have 3 times x minus 1, also from our power to a power rule. And keep in mind, there is a distributive property there on the right. 2 times 3x, well, that's just 6x. On the right-hand side, you'll have a 3x minus 3. So this is a very deja vu problem because once again it's pick on the little guy. Goodbye. 6 take away 3, well that's just 3. What will be nice is in this case we actually do get a nice whole number answer. Divide both sides by 3, x will be -1. So take a look through these three. The substitutions aren't too crazy here, but there is more going on conceptually. I'm going to switch over to the whiteboard for the next two. Definitely raise a hand if you're getting stuck with any of these problems. Just let me know what you need.
So for number 15, once again, we have two numbers, in this case 8 and 32, which are not the same. We don't have the same base here. But they are both powers of 2. So if you don't have your common power sheet out in front of you, I recommend pulling this out. It does have a list of the most common ones we deal with in this class. So 8 and 32 are both powers of 2. I'll do that substitution in green. 8 is the same thing as 2 cubed. And 32 is the same thing as 2 to the 5th. Now we don't want to forget about our original powers here. On the left I had a 2a minus 1. And on the right we had a 2a plus 1. So this is our power property. We have a power to a power. So 3 to the 2a minus 1 power. So there'll be a distributive property on the left because that is multiplication. Power to a power means multiply the exponents. And then we also have 5 times 2a plus 1 on the right. So there'll be two distributive properties that happen in this problem. One on the left-hand side and one on the right-hand side. So a bit more going on here than in some of the previous examples. 3 times 2 is 6, so there will be a 6a on the left. 3 times -1 is -3. Jumping over to the right-hand side, we'll have 5 times 2a, that's a 10a. And 5 times 1, that's just 5. So this turns into a pick on the little guy problem. I've got 6a on the left, 10a on the right, so we'll subtract the 6a from both sides. Goodbye. And since I'm moving all my variables to the right, we'll bring the constants to the left. The opposite of plus 5 is minus 5. -3 minus 5 here on the left-hand side, that's a -8. On the right, 10a, take away 6a, that means there are 4 a's remaining. So 4a is -8. Last but not least, divide both sides by 4. 8 divided by 4 is going to be 2. Negative divided by a positive will be positive. Let's try that again. Negative divided by a positive will be negative. So we'll get a -2, and that is what a equals. So again, a bit more going on in the algebra here, a distributive property both on the left and the right. But it all comes back to that one-to-one property. Once we have the same base, we're good to set those exponents equal, even if those exponents are difficult, something like 3 times a binomial. So definitely take a look at this example, make sure you're understanding where all the numbers are coming from, all the little steps in the middle, and also why we were allowed to set these equal to begin with. Let me know what questions you have. I do want to take a look at one more of these difficult examples before moving on. So in 16, the real difference is that now I have two numbers that are powers of 3 instead of powers of 2. No matter, we can still do substitution just like we did in the previous example. 27 is the same thing as 3 cubed. 243 is the same thing as 3 to the 5th. So our bases are different than last time, but the process is going to feel very familiar. We don't want to lose our original exponents, so there will be a power to a power rule happening both on the left and on the right. So again, once we have common bases, that's when the one-to-one property comes into play. Now that I have 3 raised to some power equals 3 raised to some power, I can set those powers equal. We do want to be careful because the power to a power rule tells us to multiply the inside and the outside powers. So on the left, I have 3 times 2x. And on the right, I have 5 times x minus 2. So algebraically, it's a bit simpler than the last example because now there's only one distributive property to deal with. That 5 on the outside distributes to the x and the minus 2 inside. On the left is just basic multiplication. 3 times 2x, well, that's a 6x. On the right, 5 times x, that means I have 5 x's. 5 times negative 2 is negative 10. So this one winds up algebraically being kind of no big deal. I can subtract the 5x from both sides. Goodbye. 6x, take away 5 of them. That means I just have the 1x remaining. So x is negative 10. So the algebra can be very different from problem to problem. Keep in mind in the previous example, I had 2 distributive properties, a pick on the little guy, kind of a lot going on. In this one, even though it's the same property, it's our one-to-one property, the algebra at the end looks very different. So we want to get out of the habit of every problem looking exactly the same, although the beginning steps certainly did. A substitution to get the common base, one-to-one property to set those exponents equal. Those first couple of steps will feel like a lot of deja vu. After that, though, the problems can look very different. So at this point, you're probably good to try a few on your own. Let me know what other supports you need, and I'll be here to help. After this, we want to take a look at a few where there are some fractions in place, some negative exponents. So I recommend starting this practice assignment before jumping into the ones with the negatives and the fractions. Make sure you're comfortable here before suddenly the ugly numbers come into play. See you next time.